This is Precalculus section 7.1, day 2. We'll be talking about verifying trigonometric identities. Thoughts to keep in mind as we verify an identity is to transform one side of the problem into the other. It's important to know that we cannot move a term from one side of the equal sign to the other side. So we will not be adding or subtracting cosine to cosine or sine or any trig function from one side to the other. Sometimes it may be beneficial to transform both sides of the equation, but for the most part, we usually only deal with transforming one side into the other. In order to complete the problems today, it's important to use the materials mentioned in 7.1 notes. Specifically, the techniques for simplifying trigonometric expressions. This included substituting an identity, changing terms from sine, or changing all terms into sine and cosine, multiplying by a form of 1, getting a common denominator, factoring, or multiplying by a conjugate. So we will see many examples today. For example 1, we have 1 divided by secant squared of x plus 1 divided by cosecant squared of x equals 1. So we'll be working with the left-hand side. Let's try changing everything in terms of sine and cosine. So I'm going to say change to sine and cosine. Then our expression on the left-hand side, since 1 over secant squared of x is the same thing as cosine squared of x, and 1 over cosecant squared of x is the same thing as sine squared of x, just knowing your Pythagorean identity, cosine squared of x plus sine squared of x, that just equals 1. So now we have 1 equals 1, and we verified correctly. The nice thing about verifying is that you never have to really do any math. It's more so it's completing a puzzle and just making sure you know which steps to perform correctly. So for example 2, we have 1 plus tangent squared of theta divided by cosecant squared of theta equals tangent squared of theta. So let's work with the left-hand side. I'm choosing the left-hand side because it looks a little messier, and it's usually easier to make messier sides look more clean than it is to make simplified sides look messy. So we can rewrite 1 plus tangent squared of theta as secant squared of theta. That is just a Pythagorean identity. So this becomes secant squared of theta divided by cosecant squared of theta. So now, rewriting everything in terms of sine and cosine, we will have 1 over cosine squared theta divided by 1 over sine squared theta. Now just multiplying by the reciprocal, we have 1 over cosine squared theta times sine squared theta divided by 1. So this becomes just sine squared theta divided by cosine squared theta, which we know we can rewrite as tangent squared of theta, because sine over cosine is equal to tangent. So if we have sine squared over cosine squared, that equals tangent squared. So of course, tangent squared of theta is equal to tangent squared of theta, and we verified correctly. Example 3 is sine of x plus cosine of x equals 1 plus tangent of x divided by secant of x. What we're going to do first is split this into 1 over secant of x plus tangent of x divided by secant of x. So we're splitting up our fraction. So we have 1 over secant of x plus tangent of x divided by secant of x. So we can rewrite 1 over secant of x as cosine of x, and That's just a reciprocal identity. And if we change tangent of x divided by secant of x in terms of sine and cosine, we have cosine of x plus sine of x divided by cosine of x, all divided by 1 over cosine of x. Draw some lines to keep my math straight. Now we have cosine of x plus, we multiply by the reciprocal, we are left with sine of x over cosine of x times cosine of x over 1. And notice that we have a cosine of x in the numerator and in the denominator, so those can cross out. And now we just have cosine of x plus sine of x. On the right-hand side and on the left-hand side, we have sine of x plus cosine of x. So those two equal each other. So we know we verified correctly. Example 4, we have sine of theta times cosecant of theta minus sine of theta equals cosine squared of theta. Since the left-hand side looks messier, let's start with the left-hand side. Our first step is going to be distributing. We're going to distribute on the left side. If we distribute this sine of x to this cosecant of theta, or the sine of theta to the cosecant of theta and the negative sine of theta, we are left with sine of theta times cosecant of theta minus sine squared of theta. And we know we can rewrite cosecant of theta in terms of sine. So we will have sine of theta times 1 over sine of theta minus sine squared theta. So now notice we have a sine of theta in the numerator and in the denominator, so those cancel out. And we are just left with 1 minus sine squared theta. Recalling the Pythagorean identity, sine squared of theta plus cosine squared of theta equals 1. If we subtract sine squared of theta on both sides, we are left with cosine squared theta equals 1 minus sine squared theta. So what we are going to do is substitute in cosine squared of theta for the 1 minus sine squared theta. When we do that, on the left-hand side, we are left with cosine squared of theta, which is what we were trying to accomplish on the right-hand side. So of course, cosine squared of theta equals cosine squared of theta, and we are finished with the problem. Example 5, we have 2 times tangent of x times secant of x equals 1 over 1 minus sine of x minus 1 over 1 plus sine of x. Our first step is to find a common denominator. You'll see a common trend anytime you have 2 fractions that you are trying to add or subtract. It's always a good idea to find a common denominator. Our common denominator in this case will be 1 minus sine of x times 1 plus sine of x. So in the numerator, we will be left with 1 plus sine of x minus 1 minus sine of x, all divided by 1 minus sine of x times 1 plus sine of x. So now if we FOIL the denominator, and we will also be distributing the negative in the numerator, we have 1 plus sine of x minus 1 plus sine of x divided by 1 minus sine squared of x. now in the numerator we have, notice we have 1 minus 1. So those ones will cancel. And now we have sine of x plus sine of x. So now we are left with 2 sine of x. And going back to our trig identities from the last page, since we had sine squared of theta plus cosine squared of theta equals 1, if we end up subtracting cosine squared of theta, or I'm sorry, if we notice how we subtracted sine squared of theta, and we were left with 1 minus sine squared of theta on the left hand or the right hand side, which is equivalent to cosine squared of theta. So we will replace 1 minus sine squared of theta with cosine squared of x. So now cosine squared of x is the same thing as having cosine of x times cosine of x. We'll have 2 sine of x in the numerator. We'll have cosine of x times cosine of x. Looking back at our original problem, we were trying to get something. We're trying to get something in terms of tangent and in terms of secant. So if we leave our 2 out in front, if we take sine over cosine and 1 over sine, sine over cosine is the same thing as tangent of x, and 1 over cosine can be rewritten as secant of x. So on the right hand side we have 2 tangent of x times secant of x, which is what we were looking for on the left hand side. So now we have 2 tangent of x times secant of x equals 2 tangent of x times secant of x. So we can check that off. We did our math correctly.